I am sitting down again with Dr. Jack Kruse. We're recording part 3 of our series on light, water, and magnetism. And we are going to keep delving down the rabbit hole of water. So, Dr. Kruse, thanks for coming on again.
No problem.
So where we left off after our last discussion was this idea that disease and health is contingent upon our mitochondria making water effectively and efficiently. And when that process is impaired through a range of things, such as non-native EMF exposure, then disease is something that manifests. So I'm happy to go where you want to from here, Jack. So maybe we can explain a bit more about exactly the dynamics or the process of how that water gets produced, or we can talk a little bit more about why that water is so special. So happy to go wherever you want with this.
Yeah, I would say that without getting too deep into the weeds, because it doesn't make sense to parse everything out. I think we said this in the last podcast, but we can reiterate it here, that you basically make water from metabolism that occurs in the mitochondria. That includes from fats through the TCA cycle, through glycolysis, also in the matrix, and also protein metabolism through the urea cycle. It basically, the take home for your audience is that you make more water from fats. Next best is from proteins. Next best is from carbohydrates. And the difference between carbohydrates and fats is almost a 2-to-1 ratio. So the second key point to bring home is that the water that a mitochondria makes, remember we talked about the mirror image of the spider doing push-ups on the mirror, that mitochondrial respiration reverses the photosynthetic process. The difference is photosynthesis works with all types of water. If the water is from, say, Antarctica, it's the water's from the North Pole, the water's from Australia, the water's from the United States, photosynthesis will work. But the interesting thing is photosynthesis actually has a photosynthetic yield depending on how much deuterium is in the water. The flip side is mitochondrial respiration only makes deuterium-depleted water. So again, that's one of those points where you come to and go, okay, how much do you know about deuterium? And why is this particular issue a big deal? I don't know if you want to jump down that rabbit hole right here, right now. Maybe it's just something for your audience to write down and say, okay, he said this. Maybe we'll come back to it later. But that's the basics of really what happens.
Yeah, well, we mentioned deuterium early in the last podcast as well. So I think it would be a good opportunity to explain to people what is deuterium and why it's important.
Okay, so everybody learns in 3rd grade that water chemical symbol is H2O. The H stands for hydrogen, the O stands for oxygen. What people may not know is that there's 3 isotopes of hydrogen on Earth. The first one is H+, which is called protium. That's the lightest isotope. The second one is deuterium, which is double the atomic weight. Why? Because it has a proton, a neutron, and an electron. And then tritium, which has 2 neutrons, 1 proton. That's radioactive. And tritium has no role at all in biology. It's basically used in nuclear reactors and some other industrial uses. So really the whole story with water comes down to understanding that H2O, most people think it's a homogeneous chemical everywhere in the world. And it turns out that's not true. So for example, most of your audience, as you told me last time, is in Australia and the United States. The difference between those 2 countries, let's talk about it. Australia is in the middle of the Southern Ocean. There is no land masses around Australia. It sits there. The hydrology cycle of Australia is radically different than it is in North America. Even though top of your country's at 0 latitude, Queensland about 4 to 6 degrees south, you go down to, I think, Tasmania, which is 37 to 40 south. That's not equivalent to the United States. The United States goes from about 44 north to, I'd say probably tip of Australia. I should say tip of Hawaii, and tip of Key West is probably 24 latitude. Maybe Hawaii a little bit lower, but not by much. But the difference is we have a ton of land masses there. And the land masses change the thermal haline currents. Thermal haline currents are the currents that are in the oceans and the water. And that's the hydrology cycle, that's made at a continental level, those from the clouds that rain down upon us. Why is this important? Why am I going through this whole shebang? Well, there's another reason that Australia has different diseases than we do. It's because the water that you guys make is high deuterium content water. And and I'm sure everybody who's from Australia knows that Australia is basically a desert. Everybody in Australia lives on the outside of the continent. Hardly anybody lives inside. And that the climate there is radically different, than it is, in the cities that are, around the different provinces that you guys have. What you may not know is when you have a continent or a big country that's like yours, the outside where rivers run from the center islands, the deuterium content in the water goes up. So everywhere in Australia, you're about 148 to 155 in terms of parts per million deuterium. So that means you have a lot of heavy water mixed in to your water down there. And it turns out, if you remember Einstein's equation for mass equivalence, E equals mc squared, anything that has higher mass carries less energy. So when we talk about water, you say, wait a minute, that means Australia's water isn't as good as other places. And generally, that's true. The United States, I wouldn't tell you that we have much better water than you do, but we do. Our water is better than yours. But why is our water better? Probably from the northern parts of the United States, because it turns out the way nature works, this whole water magnetism and light thing, the closer you get to the poles, the more deuterium-depleted water you get. And the reason for that should be very intuitive to you after what we said the first two parts of the podcast. Why? Because light is poor at the poles. Since light is poor at the poles, it would make sense that nature would offset this by having lower atomic mass water that's present there that would fall. And if you understand how deuterium works in continents, turns out deuterium is best at high latitudes. So, for example, in your country, that would mean Tasmania and maybe Melbourne would have better water than, say, Queensland or Darwin. And that's probably true, but in your country, it's probably only true maybe 1 or 2 parts per million. In our country, for example, or I should say North America, let's add Canada into this. Canada at the Northwest Territories or Greenland, far superior water than I would have down in New Orleans or Key West. So it turns out the closer you get to the equator, the shittier your water is. There's one big exception to that on the planet, which is part of the reason why a lot of my members go visit it. That's around the cenote system in Mexico. Why? Because remember, that was built by an extraterrestrial event. And it turns out where the asteroid hit there is right at the 20th latitude. And there's no rivers at all in this area. The whole area is made out of calcium carbonate. So all the water that the people in that area of Mexico drink is 65 million years ago from when the dinosaurs got knocked out to now. It's all rainwater. And it turns out because the landmass in that area is made out of calcium carbonate, it's called karst, over a period of time, very similar to the reaction that occurs in our blood that you learned in medical school like I did through carbonic anhydrase. The water is deuterium depleted at a low latitude. It's the only place on Earth that happens. And it turns out that's where all the Mexican people in the Yucatan get their water from. Because there's no reservoirs there. There's no rivers, which makes it a very, very unusual place. But it should be no surprise to you, based on the first 3 hours that we've already talked about, why that's an important thing. And if you don't know anything about Mesoamerican Indian culture, the thing that both the Incas, Aztecs, and Mayans all knew is that the water in their area was special. They had no idea why, because obviously most of them lived, thousands of years before quantum mechanics. But it turns out the real reason is because the water that's in their area has a lower atomic mass, and they happen to live inside the tropics. So when you take low atomic mass water in the tropics, dude, you become like a rock star. It makes you to have very, very healthy people who are very robust. And that's the reason it happens. So generally the way nature works, we take that exception out of the way. Higher latitude water has lower deuterium content. Water at the equator has the highest. Turns out Australia also is a little bit of an exception because they're the one continent that sits in, well, I should say, you're the second continent, but I'm not counting Antarctica. Why? Because that landmass has the Southern Ocean going around it in a circle. And your hydrology cycle in Australia is affected by two things. The donut hole that's over the Antarctic continent, that really affects it. And the second thing that affects it is called the South Atlantic anomaly. And because of those two things, the deuterium content of the water that falls from your clouds down there gives you crappy water. This is part of the reason why. Also, some of the diseases that are epidemic in Australia are much more prominent there because these affect mitochondria. Why? Inside your mitochondria, you're designed to have H+, which is protein, not deuterium. Deuterium destroys, how shall I say, the quantum engineering of the ATPase. The ATPase spins about 9,000 protons per second, and deuterium cannot fit in the atomic channel that's in there. So when it goes in there, it blows up. You know, it's almost the best way to think about it. It's putting a ball bearing in a carburetor of a car, just totally seizing the engine. So obviously you don't want to do that. And the other key thing, like if you look at the chemistry of deuterium versus hydrogen, the chemistry, because it has double the atomic mass, means it has a higher kinetic isotope effect. You'll see that in the literature. It goes by KIE. What does that mean in English? Very simply, that deuterium holds on to atoms much more than protium does, which is light hydrogen. Well, you can imagine that's a big deal in mitochondria because if you study them, like let's just talk about the most common reaction in mitochondria, which is NADH and NAD positive. That H positive has to be protium and it has to recycle at cytochrome 1. So if you have too much deuterium in your matrix, the kinetic isotope effect basically limits the flow of hydrogen inside the matrix. And just so everyone's clear, we actually know what the kinetic isotope effect is. One deuterium affects the hydrogen bonding of 96 H plus atoms. So that's 100 to 1 effect. So when you talk about mitochondria making water, you would just, even if you didn't know any of this information, you go, that's a pretty damn big effect. It's definitely going to have an effect on the efficiency of mitochondrial respiration. So for those of you who are really paying attention to the story, let's flip this around. Is the same thing true in photosynthesis? And it turns out it is. It turns out if you use deuterium laden water, for example, you have 40% deuterium laden water, it reduces crop yields by 40%. So this should really open your eyes because most people in the health space don't really know a lot of botany. They don't know a lot about, the food webs. And it turns out deuterium has a role. Most people who teach about this always give you the negative connotation of deuterium. Deuterium does have some positive connotations. I mentioned in, I think it was the last podcast we did, which was the first part on water, that our blood is designed to have pretty high levels of deuterium in it. I didn't tell you back then what the reason was, but I can tell you now. My whole Vermont 2018 talk, I don't believe that's public. It's on my Patreon. But what the gist of it was is that when you squeeze deuterium down, either electrically or magnetically, from solar exposure, anytime you compress deuterium, it creates massive amounts of UV light. And the UV light that it creates is light stronger than the sun. So Max is probably going, wait a minute, that goes back to our first 3-hour podcast. This is another way that our body can make light that's stronger than our sun. So then you begin to understand why deuterium has a role in the peripheral circulation. The other big effect of deuterium is actually a quantum mechanical effect. And this is one that a lot of people don't know about. My members know about it because I've been talking about it for a long time. And this will probably get into, maybe we're tipping forward to part 5 or 6 when we get to magnetism. Deuterium has a different magnetic moment than H+. What does that mean? The magnetic moment is a nuclear spin effect of atoms on the periodic table. And it turns out that H+ and electrons have what we call a half nuclear spin. Okay? That's the most favorable. Deuterium has +1. What does that mean? It means that it's not affected as much by magnetic fields as H+. So obviously, that should be a big clue to you what's coming down the pipe. And to give you like a little preview, and I'm not going to go into it too deep here, the main reason that turns out to be important, one of the major effects quantum mechanically of a mitochondria, besides energy production, is to create a quantum entanglement. And the way you have to entangle particles, you first have to make them quantum coherent. And it's much easier to create quantum coherence when all the nuclear spin of the particles that are in the thing that you're trying to do all have a half nuclear spin. So on my Twitter feed, since you and I did the first podcast, some people have asked some pretty good questions. And I told people that the surface of your skin, when sunlight hits it, the arterioles are designed to come to the surface. You're designed to make vitamin D. You're designed to sulfate cholesterol. Your UVA light brings that surface to create the deuterium pinch, to create UV light there to affect all, the extracellular matrix. But one of the other big effects that happens, this creates a shell. I would like to use the word force field, but that's not really, I don't want people to go think I'm talking Star Wars stuff. I want people to realize what I'm saying here. This shield actually is important for shielding the rest of the body so that quantum mechanical properties can happen. So if you talk to a physicist, one of the things that they've been stunned about is none of them, up until 2007, ever believed that you could have quantum mechanical processes happening in warm, wet environments, which obviously is what sentient beings are, meaning whether you're a plant or an animal. And it turns out, we found out in 2007, that every single step in photosynthesis is quantum mechanical in nature. What leaves do, when you actually read the papers that were done back in 2007, will absolutely stun you. Like how an exciton is created and how it travels with no time to get to the reaction center to do things it does. It's almost beyond belief. And the reason it's beyond belief is because it doesn't follow classical physics. It doesn't follow classical chemistry. It doesn't follow classical biology. But if you remember what we said in the last hour, we said the entire food web on this planet is linked to photosynthesis. So let's take the next step here, Max. What does that mean? That all of your food fundamentally is quantum mechanical, okay, at a very fundamental basis. So when you hear me in other podcasts, you and I haven't said this yet, but this will be the first time I say it in our podcast, is that food effectively is an electromagnetic barcode of the sunlight as you rotate around the sun. And your mitochondria has the full capability of deciphering that electromagnetic code based on where you're at. So it turns out the light through your eyes, the light through your skin, the light through your gut, your body and its mitochondria are accounting for that. So I'm going to use my country because it's easier to make this point. If it's December 31st and you're eating a banana in Boston, so that would be the winter, eating a tropical fruit on one of the days where it's the shortest time of the year, so there's not a lot of sun around, you basically create chaos inside your mitochondria. Doesn't mean you can't do that because Whole Foods sells that banana in Boston, even though it doesn't grow there. But when you eat it, you create chaos in the mitochondria. What does chaos have another name for in medicine? It's called inflammation. And what is inflammation fundamentally, Max? You remember this because I know you learned it before medicine. It's a pH scale, isn't it? It's a logarithmic scale of what? Hydrogen protons. Oh, we're back to this hydrogen story again. And you begin to realize that the way hydrogen atoms are controlled in the body is really, really, really important. In fact, it is so important that when people want to focus on macronutrients, I get very, very angry because of the story that I'm laying out for you now. But see, that macronutrient story is really easy to understand. Stuff that we're talking about right now, that's not so easy to get. You have to know a little bit of biology, a little bit of chemistry, but a lot of physics. And you know that most people in the health space, they don't know a lot of physics. And they certainly don't know enough physics to understand truly what's happening between food, mitochondria, and then the larger classic level. Because most of us experience our environments through classical physics, meaning reality. But everything that's happening to you in the food web and everything that happens to you in your mitochondria is all quantum mechanical. Why? The input to mitochondria is via electrons. Those electrons come from food. And there's recycling inside the matrix of H+. And I've always asked doctors when, they come to visit me or I do podcasts with them, I said, haven't you ever actually thought to yourself when you read a biochemistry book and your head was exploding, remembering all the different enzymes and glycolysis and TCA, why the hell nature's doing this? That simple level of question you should ask. But when you're learning this stuff, no one ever does. I didn't initially when I learned it, but I realized 20 years ago why it was important, because it turns out that nature in your mitochondria has built your mitochondria to pluck only H+ off. It limits the amount of deuterium on the glucose backbone or the fat backbone. And what do? We collect like crazy H+ inside the matrix. In fact, when you collect H+ in the matrix and strip the electron off, H+ actually acts like a metal plasma. And it then takes on new materials, or I should say new physical capabilities. So for example, most people know about metallic hydrogen because they've heard stories about what the core of Jupiter is. And everybody knows that the core of Jupiter has a massive, massive magnetic field. I mean, it affects everything. In fact, going back to our first 3-hour podcast, many people would be surprised to know that many people believe that the asteroid that took the dinosaurs out was steered to the Earth by the magnetic flux from Jupiter. So for you to think that this is not a big deal, I mean, I'm giving you a lot of different facets to the story to make sure you understand that it is a big deal. And it turns out when you collect a ton of H+ without its electron, it acts more like a metal plasma. That means it becomes flexoelectric, it becomes piezoelectric, and it also becomes ferroelectric. Those are all quantum mechanical currents that do different things in the body. Now, we're not going to talk probably about those in this podcast, but I want to make sure you understand what's really fundamentally happening at the mitochondrial level. Inside that matrix, we are collecting H+ like demons. Why? Because that H+ is going to be recycled at cytochrome C through all the different steps in TCA. And you guys can open up a biochemistry book and look, like at aconitase, fumatase, and also, I'm trying to think the other ones, malic acid, I believe. That's where water comes off. Those are all the steps where water is created. And when you see it, you'll realize that the body only wants to make H+ 2O. Now that's where the story stops in the mitochondria. Now where the story gets more interesting, Max is probably going to ask me this question if he doesn't let me keep rambling on. Jack, is H2O the key water actually in our bodies? And it turns out it's not. H2O has to be impacted by light. And this is where a water researcher that I never mentioned his name, but I did tell you he came up with a book in 2013, 2014. He's very easy to understand. His name's Gerald Pollack. He's at the University of Washington. He wrote a book called The Fourth Phase of Water. I'd strongly recommend to any of your readers, if you want to learn really cool things about water, read his book. I will tell you, not everything in that book is true, okay? It was true in 2013. It's not true anymore. So you have to parse it out. I knew about this whole water story before Gerald Pollack wrote his book because of the stuff that we talked about in the first 3-hour podcast about pumps. And I was turned on to 3 different water researchers who Pollack, I believe, knows, but who were way early in the water game before he got into it. One of those guys was named Wiltsey Robinson. He was at Texas Tech University. Another guy was Julian Caparda. He's an Italian researcher who's a physicist who eventually limited his specialty to water. And then Emilio Del Giusse, who's another Italian, also physicist, that became fascinated by the physics of water. And the things that they found, and the reason I came to them before, goes back to the original question that I brought up to you the first podcast we did and the second one. I said to you the first step of photosynthesis, the charge separation of water, took 12.06 electron volts. I said, wait a minute, this is crazy. How did we do this? That's when I found out the answer from those guys' work. And I was like, this is really interesting. And that's the way I jumped down the rabbit hole. And from their work, I found out that water is able to be charge separated by visible light fundamentally because it changes its physical chemistry from H2O to different molecular formats. And the reason that happens is because light changes the hydrogen bonding angle that's present in it. So the way for you to think about this, if you don't want to get caught up in the science, think about a piece of charcoal and a piece of diamond. Everybody should know they're both carbon. But what's the difference? Is the bond angles in the cube, or I shouldn't say the cube, but in the molecular crystal of these two formats. You need to think about water exactly the same way. Ice is different than liquid water. Gaseous water is different than liquid water. But it turns out within liquid water, oceans, your tap, and inside your mitochondria and in your blood, radically different. And it turns out that biology takes full advantage of the interaction between water and light. For example, water acts differently at different scales. What do I mean when I say that? When you have like a scale, this is the macro scale. I have a glass of water right here that have ice in it. This water is not capable of doing the things that water can do in Max's microtubules right now. Max's microtubules have a spot on the rostral end that's probably about 10 nanometers, which is pretty big. At the distal end, closer to where the action happens, goes to 1.4 nanometers, 1.6 nanometers. When water is confined in a microtubule to that level, it becomes quantum mechanical. It does things that almost defy belief, okay? And people are unaware of what I just told you. So it turns out not only does water change its physical bond angles and chemistry, it also changes its abilities when it goes from the classic level to the quantum mechanical level. So it's almost like an amplifier effect with water. But you have to realize it's the ultimate chameleon. But the reason it's the ultimate chameleon, because it's made from the ultimate chameleon atom on the periodic table, which is H+. And all of this stuff, for people who think that this hasn't been well worked out, I promise you, you're incorrect. The physicists that figured out the difference in ice, in different ices that's present, like the clathrate gases that are in the tundra up in the Northwest Territories, even the ice in the Antarctic ice channels that we pull out. We've learned a tremendous amount about the chemistry on Earth over the last 2-3 billion years from looking at these ice cores. And some of the things that we're talking about today, that science was used to figure a lot of this stuff out. The problem is these guys that worked on this, they were physicists that eventually said, well, if this stuff has a huge effect on Earth, it must have a huge effect on life, because obviously the same thing has to be going on inside of us. And I would tell you, probably since when Wiltsey Robinson first started looking back into this, was about 1993. Proparta and Diucie looked into it from 93 to 2000. Proparta died in 2000 suddenly, which was a huge blow to water researchers. But Diucie continued on and continued to publish a lot of good stuff. And then obviously Pollack made his transition fully to water because he was interested in muscles, he was interested in cells, and he realized that water was really the key. And then there were some other researchers, a mathematician, and eventually a physicist named Mei Wan Ho, who was friends to all these guys, who wrote books. And she proved the quantum mechanical nature of living things. Why? Because she decided to take cells and put them under a polarized microscope. And if you understand water, because H is positively charged, oxygen is negatively charged, that means it's a very polar molecule. Anything that's polar has a polarization effect. So she put cells under a polarized microscope and she saw birefringence. And she knew immediately from looking at the birefringence that there had to be some magic going on at a quantum mechanical level in living tissues. The interesting thing, Max, my podcast with Rick Rubin and Dr. Andrew Huberman hasn't come out yet. You trumped them a little bit. But this came up in the podcast, and it probably interests you as a doctor. That's the reason I'm bringing it up. Dr. Huberman uses cephalopods in his lab at Stanford University because he's a neurobiologist that is interested in the visual cortex, of humans and how it operates. So he uses them as the animal. The interesting thing is I don't think he realized that cephalopods evolved about 10 million years after the Cambrian explosion. So I said to him in the podcast, I said, do you realize that you're studying an animal that has the first iteration of the human brain in it? And I said, you see all those lights as they swim around, and you're amazed at where they come from. And you have no earthly idea that it's being created by the water that's inside them from actually the extreme low frequency UV light they release. I said, the difference between them, they're like human brain number one. We're about human brain 1 million. It's just been layers on top of layers that have added, because when you look at the human brain, like when I go in and take someone's skull out and I'm doing brain surgery, I don't see the same thing that happens, in the tank that is at Stanford University and Dr. Huberman's lab. But the point I want people to understand, and I think you and I talked about this in the last podcast, is that the human brain is filled with water and surrounded by water. And when you actually think about it from that perspective, and you think about what I just said about cephalopods and how water reacts radically differently, you begin to realize that some of the peculiarities that you learned in medical school, Max, about the human brain, about those circumventricular organs and the subarachnoid space and things like that, you start going, nature doesn't really make mistakes. She's been engineering around these factors in water and hydrogen and oxygen for a really, really long time to allow us to do the things that we can do today.
I really want to frame this idea of deuterium and help people understand it. And as you said, most people have no concept of the different types of hydrogen. And maybe, I mean, my understanding of deuterium was just it's heavy water. So it's a form of heavier type water. But the question that I had was, and that maybe many other people had, is that if there is a greater amount of heavy water around the equator and less in the poles, humanity evolved in the Rift Valley of Kenya, which is much, much closer to the equator. So are you implying that ancestral people who lived around the equator and in places of higher deuterium in the water was somehow living less or having more disease compared to the humans that were living at higher latitudes? And if we're trying to square this with evolutionary biology and the fact that humans only came out of Africa however many 200,000 years ago, how does that
We think it's 70 to 100,000 now.
So
it wasn't that long.
How do we square that difference?
We actually already squared it. But the funny thing is, I don't think you've realized it. What did I tell you the first 3-hour podcast that made this story interesting about Pomsey? I said these mammals had small little brains. Do you think the first hominids had the type of brains that we had? The answer is no, they didn't. Remember, we were rapidly evolving. And I told you that I think the evolution between chimp and man happened way faster than we all think. I don't think it was 2 to 4 million years ago. I actually think it's probably happened in the last maybe 400,000 or 500,000 years. And I think we now know, like when I was in medical school, we believed that humans left 200 to 400,000 years ago out of Africa. I think now the number, after 30 years, it's now 70 to 100,000. So you see how that number is getting closer to real times? So it turns out the real issue isn't in disease, Max. I think actually it's in complexity. Why? Because our brain, compared to the Homo versions of the primate tree that we know of, is far more complex. There's only one evidence that we have in the fossil record where there's a primate that was in Homo that had a bigger brain than us, and that was the Neanderthals. And they died out. They had 125 grams more cerebral tissue than we did, and as soon as they got to a high enough latitude, they disappeared, kind of like the dinosaurs did. Now, we still have a lot of their ancestral DNA parts in us. We know that. It's not very much, but it's there. But for some reason, having a big brain on this planet when we got to a certain latitude seems to be a thermodynamic rate limiting factor. So I would not say, I think the connotation that you asked me in the question, I'm asking you to check yourself. I don't believe that the level of deuterium was related to disease. I think it was related to complexity of the brain. And I think what happened, that evolution continued, and what drove the process. Remember, if you accept what I told you the first 3 hours, that everything about us is semiconductor. How do semiconductors work? When light hits semiconductor, it creates a current. So you need to realize that we had, at our genesis in the East African Rift, the best light that one could imagine. What was the thermodynamic givens that changed? It was actually the amount of DHA in our central retinal pathways, and then in our brains, that was the real big difference. And if you really are following me along, this is the question you should ask. And I think I told you this with the hope that you'd understand it. Do I believe in our evolution there was a period of time that we sheltered, likely in caves? We know that's not controversial, but it should really get you thinking to what we said in the first podcast. That would make sense, because what did I tell you had to happen in that primate to Homo transition? But we had to suck more of our hair and our melanin inside our heads to create this. And if you think about it, sheltering yourself from strong UV light in caves for a period of time, that's exactly what would have happened. You would have started to pull melanin inside your head while you weren't in the forest anymore, because you were foraging at the sea for things like DHA in shellfish, fish, and shrimp. that would have fostered a huge change while you're consistently in tropical sun. And here's the best part of the story. This is, like I said, part 5 and 6. We believe the East African Rift, where we came from, best data available, 3 tectonic plates come together in that area. So magnetism was clearly there as well. So you had massive physical forces scoping this transition, all acting at once. I think today, the people who have brought deuterium, I think marketing wise, want people to think of deuterium as a negative connotation in disease. That's not how I think about it. I think deuterium is one of the things that sculpted what we became. And it's really important to understand how sunlight works with deuterium on our surface. And if you really think about this, Max, from your medical training, understand that through your eyes, just when sunlight hits it, 40 to 60% of your blood volume goes through your eyes when that happens. The same thing is true on your skin. When you're in sunlight, you get massive shunting of blood to the surface. If you think about that blood being filled with deuterium, wouldn't that also create another field around you that would protect your interior that's filled with electrons and protons so that you could perform quantum coherence and eventually entanglement? Because it turns out that's the real magic that's going on inside of us. And when you think about the construction from that standpoint, like the physical organization of mammals and what they're really up to, they are absolute magicians at utilizing UV light. And what we're trying to paint the picture here is that water, especially deuterium-depleted water and water with deuterium, act radically different with visible spectrum light.
Yeah.
And that means that was really, really important in terms of our transition at that time. I think you're correct in saying that many people probably have read Gabor Somali's book, Defeating Cancer, and they want to use deuterium-depleted water to treat cancer. That's great. But realize that at our genesis, much like I told you about the small mammals and the T-Rexes, the thermodynamic givens today weren't what they were then. And I think deuterium actually has a huge role in actually scoping us. I don't think it's just a disease factor. It's become a disease factor now because now we've introduced electromagnetic fields that cause topologic problems on our surfaces, meaning our eyes and our skin. And that goes to the point that I'm trying to make to you right now, that those were not present at our genesis at all. They were not around. And I would even venture to say, I don't even think fire at our genesis was likely around then. I think the only thing that those original primates and original Homo species got was when we had a lot of clouds in, we'd let more cosmic radiation in. But that's, normal extraterrestrial stuff that we know happens on Earth. Probably the number one most common thing that we would get would be lightning that would, introduce X-rays and things like that. But our biology, our epigenetic toolbox can easily take care of that stuff. I don't think that stuff really is as important as the stuff that we're trying to do right now. And I think if you listen to this second part of the podcast and have in your mindset that deuterium is always tied to disease, you're doing yourself a disservice.
Yeah. And can you clarify for the listener the process and the degree to which consuming deuterium-rich water impairs or interferes with the mitochondria's ability to make deuterium-depleted water? Like, how much is that
It
influenced?
won't impair at all. That's going to be the good news for you in Australia. Like the way your system is built, you're designed to keep deuterium out of your mitochondrial matrix. The problem becomes when your redox power drops in your mitochondria, you lose that ability. Then deuterium does get it. See, that's the disease side of it. That's the pathologic part. What we're trying to lay out for people now is the basic physiology, like how it's designed to work. And you really want to keep all that deuterium in your circulatory system. That's where you want it. Remember, your red blood cells are the only cell in your body that doesn't have what, Max?
Mitochondria.
No mitochondria. We lose them. Mature red blood cells have no mitochondria. And I think that's part of the reason why this organization is present. And I don't believe deuterium is really pathologic in that way. I believe when we do develop heteroplasmy, that's where the story changes. Then we could talk about that. But I don't think where we are in this story right now, that's the path that you really want to jump down.
And this is a perfect opportunity to elaborate on the concept of cellular redox and how it relates to health and disease, because again, that's not a concept that a centralized MD or has any concept of.
Yeah, this one is really easy. Remember what we said before, that inflammation is a function of the pH log and pH is H+. What is redox? It's the opposite of that. It's the net negative charge inside a cell. So I think everybody knows, whether you have a science background or not, protons have a positive charge, electrons have a negative charge. What do electrons interact with is light. And light powers up or powers down the power of electron, but its ultimate charge is still negative. So the goal in health is to create as much net negative charge as you possibly can. And if you think about where life came from on this planet, it came from the ocean, maybe now you understand why. Because when light hits water, a charge separates and it creates hydrogen, oxygen, and 2 electrons. So basically the sea is an unending plasma filled of electrons. And then you may begin to understand what we said the last podcast about water, that babies are born 80% water, and Uncle Jack is 55% water. That means that you have less electrons in your body. What's the implications of that? That people in Australia's head are going to explode when I say? It means the older you get, the more sun you need. It's exactly the opposite what you guys are being told in Australia. Now, it's not the opposite of what we get told in the United States, because I've been telling people that forever and ever and ever, and backing up the story with science. The problem is you guys need to understand this and why it's important. So the net negative charge in you is fundamentally made, like getting back to the water story. When light hits water in a cell, it charge separates. You read Pollack's book, which I hope most of you will do when you listen to this podcast, you'll find out that when any light hits water, it changes the form. It becomes H3O2. When it becomes H3O2, it also excludes protons, meaning it excludes the positive charge. So when you put an electrode and you measure this, what he calls easy water, what Impaired and Diucie call coherent domains, they're one and the same. It's the same thing. It's kind of like, this probably won't hit because you guys don't do baseball in Australia, but we call a full count and a 3-2 count. They're the same thing in baseball. They mean the same thing. It's just different term for it. Coherent domains in water is the same as Pollack's idea of exclusion zone. How you need to think about it, it's basically a redox pile of electrons that then your body can use quantum mechanically to do stuff that you need. And if you understand what we said in the first 3 hours, I told you everything in us is about semiconductor. You need a lot of electrons to run semiconductors. And it turns out the real story that we're laying out here, Pollack, Impaired, Diucie, they are the guys that showed the first way for you to create a huge amount of electrons is charge separating water. That's like the big take-home message for you to get. Now, the part that I'm about to bring to you that you probably haven't been told, I don't think anybody's been told this, guess which is the best way to charge separate water? The melanin. Melanin is the ultimate charge separator of water. Okay? So that means that you create more free electrons any place where melanin is in your body. This is the reason why when you're a mammal, you want to pay attention to that. It's a really big deal. And this whole story with water being charge separated, I believe that you can live healthily in Australia, even drinking shit water, as long as you're doing smart things in the sun. The big problem in Australia is you guys all live on the outside of the continent, so your population density is closer. Since all of us are now using electromagnetic devices, TV, internet, cell phones, you name it, that is equivalent to like putting your head inside a microwave oven. Why? Because we're closer together. And that induces topologic changes. Now, when you add all these other little things up, your redox goes down. Most of you guys are Northern European. You all have atrophic skin. You don't have any melanin in your skin. You begin to see very, very quickly from the things that we've talked about in the first 3 of these podcasts, why someone who lives in Australia is going to have an altered redox. It's blatantly obvious. And that leads, to different issues. Most people, probably through the 50s, 60s, 70s, and I'd even say 80s, even in Australia, didn't have a problem. Why? Because our modern life wasn't built around technology. That changed. Like I always tell people, we'll use two. I'm trying to use two ideas. Olivia Newton-John and Farrah Fawcett. They were really, really popular in the 70s and 80s in both of our countries. And to see how both of those women got taken out. Remember, they were always in great shape. They did great things, but what were they constantly doing? They were around electromagnetic fields because of their acting career and also because of the music that they performed. And it's not like they lived in bad places. And the reason I bring them up, just like the reason I brought up Steve Jobs in the past, I want people to understand that this idea that your facade determines your health is absolutely horrible. I tried to bring that point up when I talked about one of my members who passed away. I happen to have a member who's very prominent in Australia who passed away. And he was warned just like I told everybody else. I don't think people really understand that you can look like Michelangelo's David and still get taken, to the morgue. Your facade is no tell at all. It's a part of it, but it's not everything. And the flip side of that, I would tell you, there's a lot of people out there with great facades that don't have great brains. And when you consider that our species buries the mitochondria here in our heart, and that's what we all die from, whether it's Australia, United States, or Europe, humans tend to die from brain and heart diseases. I'm hoping that over the next 30, 40, 50 years, like when Max is my age, that this message really gets out, that we need to focus on where our mitochondria is, because we're not gorillas. We're not designed to bury, our mitochondria here in our biceps. That's what gorillas do. But they also have a radically different physiology than we do. They have 30 feet more of intestines than we do, and they're designed to turn carbohydrates into short-chain fatty acids to do it. But they have a very, very small brain. But they have incredible strength. And most people don't even know this about chimps. Chimps are not like gorillas, but you know that chimps have 5 times the strength of humans? For the same reason. Why? Because they bury more of the mitochondrial density in their muscles.
Yeah.
So I want people to understand that water is very, very important for many of the things we do. But out of the 3-legged stool, it's probably, my opinion, the simplest to understand. The real issue with water is you need to understand that some of the stuff that it can do, it's like the ultimate acrobat in the circus that does things and you go, how the hell does this happen? And because most of the things that happen with water are quantum mechanical, and it turns out water is the most common molecule in our body, but it's also the smallest. So on a sheer basis, we are more water than we are anything else. And that freaks people out when they hear it, but it's true. So the fact that medicine spends so little time teaching doctors about water should blow your mind.
Yeah.
And nothing that happens in the TCA cycle, glycolysis, the pentose phosphate pathway. I mean, you name the pathway. None of it happens without water.
Yeah.
And you cannot study, biochemicals outside the water framework. But guess what? That's what Max was taught in medical school. That's what I was taught.
Yeah. Jack, I want to go back to quickly redox, cellular redox, and this idea that all our cells have a net negative charge in them. And when we lose that net negative charge, perhaps when we're losing energy to our environment, then that is when disease is manifesting. We, in our last podcast, we talked about mitochondrial heteroplasmy and the fact that when we have mitochondrial heteroplasmy, that's also when disease manifests. My question for you is that, is there any situation where you can have normal cellular redox and mitochondrial heteroplasmy, or
Yes.
there
question.
is?
Yeah, there is. And I have on my blogs, if you read them, I think the first time I ever posted it was in the Energy and Epigenetics series. It's either number 3 or 4. I posted a picture of basically redox between cytochrome 1 and oxygen. And health is negative 400 millivolts, all the way to about negative 200. If you live between negative 200 and 400, that's healthy. But that's when you get Doug Wallace's 10% per decade. Once you drop below negative 200, then heteroplasmy goes up on a logarithmic basis. So that means, when you understand what I just said, you could technically be 6 years old and wind up with a retinoblastoma, and the eye cells may have a heteroplasmy rate of an 80 or 90-year-old. That's the key. And it turns out that every tissue in your body doesn't have the same redox. Like, everybody thinks, well, because all these tissues in my body are me, it's all the same. No, I told you when we first started talking about water in the last one, about these compartments and space-time continuums. Every single organ in you, in fact, even different islet cells like in the pancreas, have a different zip code for redox. And it's really important for you to understand that circadian biology and all the things that we're talking about control all of these processes in you. So the key is, you are designed to be in nature. You're not designed to be listening to me and Max on the computer screen. Unfortunately, Max probably doesn't want me to say that for his podcast, but it's true. And the thing is, it's important for you to get this message because we want you outside.
Yeah.
And the more times you spend outside, the less time you spend, like for me, the less time I spend in the operating room taking care of people is big. Yeah. And do I understand that I'm trading time for money by doing the things that I do as a doctor? I completely understand. If you don't think that it doesn't kill me when I have to go in the middle of the night because I know exactly what I'm doing to myself, you're wrong. It bothers me. But at the same time, everybody has to make trade-offs. Just like when you find me on social media, you'll see I tell people the same exact things. I don't sugarcoat anything for anybody. My mouth's not a bakery. I want to tell you the truth.
Yeah. So basically what you're saying is that the heteroplasmy is a downstream effect of when redox is impaired in a cell in a particular tissue.
Correct.
Yeah. And the things that we can do to improve the cellular redox that we've alluded to in these past couple of podcasts have been getting sunlight, being exposed to sources of electrons.
And cold. Sunlight and cold. Those are the two big things. Why? Because all the wideband semiconductors in us, that's how they operate. Yeah. They become more thermodynamically efficient with visible exposure of light and also with cold. That's the same reason why you can make more dopamine in your frontal lobes when you apply UV light to your exterior or you're in cold water.
And the
cold also, it blows people's minds when they think about it, but the reason why is because the way in which we create dopamine actually tells the story. It's not the story that's in the biochemistry books.
Yeah. And the observation that disease arises when that negative charge is lost, is that something that has been worked out from first principles, or is that been observed in like a cohort studies, or how did we come to that understanding?
Actually, it's actually been borne out not only in biochemical stories, it's been borne out in nutrition studies, But the guy that really hammered it home has been Doug Wallace. In his studies, he's been the guy that's pointed it out best. And the real issue for us is biochemists, when they were first working biochemistry out in the 30s, 40s, 50s, 60s. Remember, they were looking at these pathways. A lot of times, they would homogenize the tissue and take the water out, and then try to understand what was going on below the cell level. And when you realize that, that's the reason why charges were not big in early biology. The people who really got it was the original guys, like Linus Pauling and Albert St. Georgi in the 30s. They're the ones that actually said that I think that all proteins are semiconductors. Why? Because they were studying the system in whole. In fact, when Otto Warburg was around, same thing. They had much better perspective because of the way in which they studied. The methodology back then was better. Today, the methodology is terrible. We have this reduction mindset that we can take a cell apart, look at the individual parts, and figure out how it works. But that's when you understand how we really work from a quantum mechanical effect, that is the last thing we can do. In fact, all the parts have to be present with atomic specificity to truly understand what the hell is going on at the subatomic level.
Yeah.
And that's what makes the decentralized perspective different. But when you want to explain it to someone who's not deep in science, just telling them that their net negative charge is really a good proxy for disease and health. And you want to maintain that. So the best way for you to do that is actually to make sure your solar exposure is good. What's the easiest proxy for people to use? Your vitamin D level. That's why the vitamin D level has been used. It's not the only way. I mean, I've written blogs about, how I do it. I actually use MRIs to do it. Why? Because I'm a brain surgeon. So I use MRIs all the time. But there's also blood tests that you can use. I cover those in my book. I cover those in my blog. I don't want to get into the weeds on that stuff because, to be honest with you, I don't think what we're laying out here that's important. You're interested in that? Go read the blog. Go read the book. It's there. It's not difficult to get. Most doctors, even most functional doctors, even the naturopathic doctors, most of them know what those labs mean in terms of, your redox standpoint. The key is for you as a patient, when your redox fails, realize that there's only two things that you really need to use to rebuild it. I don't want anybody to think that taking a supplement or eating a certain diet is going to improve your redox, because it doesn't. That is total bullshit. And anybody who says that, I will push back on them really hard. Why? Because it turns out diets are important for really one thing. Giving you electrons, giving you those protons, creating water in you. But the physics that are tied to your cell, that's totally tied to the energy throughput that's coming in through the system. That's where the environment really dictates a lot. And I will say that when you are sick, the reason that high-fat diets, high-protein diets are better than high-carbohydrate diets fundamentally goes to what I said at the beginning of this podcast, because they create more water. That is absolutely axiomatically true. And the way that I want you and all your listeners to think about it, whether you like it or not, the reason why is you create more water, you create more electrons. You create more electrons, net negative charge. That's really as simple as I can make it for people to understand. Why? Because electrons are what carry that negative charge. And then sunlight powers those electrons up by the photoelectric effect, which is Einstein, not Jack Kruse. But the more light that those electrons carry, then the more magic happens, from the things that we talked about in the first 3 hours, where palm seeds. And when you understand that palm seed makes melanin, and melanin does more charge separation of water to create more electrons, all of a sudden you start going, okay, this is beginning to make a lot of sense. This is really a game of collecting electrons and limiting what protons can do to us.
Yeah, fascinating. And
that's the story of water.
Yeah, and I really want to harp on the point of cellular redox, because what I think Dr. Kruse is giving us is a framework of understanding of what optimal health is. And it's a very deep, fundamental understanding based on physics and based on biophysics and the cellular level. And if we contrast that to mainstream medicine, there is no framework for optimal health. We just have increasing incidence and rises of chronic diseases and cancer. And the best explanation we have for why they're developing, other than tobacco smoking, is, it's genetic. So we're left so unfulfilled in terms of a coherent explanation of why disease is developing under the traditional Western allopathic medical model. And then we take a step further into maybe the dietary, functional medical space. And there's a biochemical framework, which is that presence or absence of something like insulin resistance and metabolic dysfunction. And that's something that I've had a lot of interest in and talked about. But even that, and that is good, because the absence of metabolic dysfunction is a good predictor for avoiding the development of chronic disease. But that in itself hasn't got the resolution or explainability that the theoretical framework that Dr. Kruse has presented has. It's nowhere near as granular. So what I feel like is so important is that we've got a further refined framework, which is based on at the cellular and subcellular level, which can give us an indication as to whether someone is going to become sick or not going to become sick. And that is based on electrons, based on cellular redox, and the things that either promote or lose energy in the and electrons in the cell. So I really like that.
Important.
Sorry, go on.
It's also important for patients to realize that this is like the via negativa of centralized medicine. You begin to realize, like, the things that have always amazed me is how in 50 years we convince people to wear sunglasses and sunscreen when this is exactly the wrong thing to do. But we did that because it was a political and societal push, because we had a surface level of understanding, because everybody assumed, well, when you get a sunburn or you get blistering or this and that, it's a problem. And no one ever actually questioned that framework. And I think the same thing that's going on with diabetes now and with obesity, when you actually start to put it together, you begin to realize that many of these diseases can be reversed. See, that's the other cool part of what I'm saying. I mean, I'm not actually just telling you that this is the pathologic, creation. I'm telling you that if you really fundamentally understand this, you have quantum mechanical nonlinear optics built into you that allows you to completely regenerate diseases. The problem is, when you have a broken mitochondria, when you have broken redox, you have to do things that are very unusual to what the paradigm, to what your mom and dad, to what your sisters and brothers and your friends think is normal. And I think the only way you're going to get behavioral change to get that understanding is actually taking the time and listening to, like, the 5 hours that we've put, or now 6 hours that we've put in the can, and begin to parse what I'm saying. And as I tell everybody, I don't want you to believe a damn thing that I say. I want you to fact check everything, but I'm waiting for someone to tell me I'm wrong. Because I can tell you, I've done it in thousands of patients, and they get better.
Yeah, and I want to make the comment about things like the carnivore diet, because it's obviously that dietary protocol is something that induces disease remission in metabolic diseases, in autoimmune diseases, in ketogenic diets, in cancer, reduces disease progression. So, and what Jack's saying is that he's explaining that through the fact that these are methods that we can increase electron bioavailability, or availability to the cells. So is that, if I'm correct, Jack, and you're basically saying that that's just one strategy, and maybe in your opinion it's an incomplete strategy of improving cellular redox, but right, it's one strategy of getting there.
Mm-hmm.
Yeah. Okay. Well,
right.
I mean,
there's some things that we do advocate. I was just going to say, there's some things that we do advocate in conventional medicine that are positive for redox, but they're few and far between. Many of the things that we tell people to do actually hinder redox. And I want people to know that. before they actually physically just go and swallow the pill or slather the stuff on their skin, that they have an opportunity to do their due diligence. And I think unfortunately, we said this off air, but I think it's the point of time to talk about it, is that after what we've all lived through globally for the last 3 years, this is the perfect time to question everybody's opinion from a centralized institution, because we found out that most of what we've been told the last 3 years needed to be questioned, and very few people did. I'm telling you, this story goes back probably 75 years. There's a lot of things that we probably need to question.
Yeah.
You know, why we do what we do. And I think when patients become more informed consumers with better information, I always like to tell my members, when you know better, you do better.
Yeah. And again, there's something I like to say to my patients when they come in with type 2 diabetes or high blood pressure, and or they're on, say, Ozempic for weight loss. And look, I say to them, you don't have an Ozempic deficiency. You don't have a metformin deficiency. What the model that Jack's laying out for you now is that you're likely having an electron deficiency, and not a pharmaceutical drug deficiency. And the answer to that disease state isn't the pharmaceutical drug; it's things like sunlight, things
Collecting
like
electrons,
and something like even a low carb or carnivore diet, because you're increasing your cellular redox, and therefore actually addressing the root cause or the underlying cause of perhaps why you develop disease in the first place. The other point that I wanted to ask you about, which is with regard to the development of chaos, because when you mentioned when we eat foods out of season, we're basically consuming a photosynthetic barcode that is incongruent with the environment which we're living. And I don't think, Jack, you mentioned this up till now, but I'll say it for the listener, that the mitochondria are also a form of environmental sensor. Well, you did say it in a different way. So that your mitochondria in your cells are sensing the environment, and they are operating at a certain way based on those environmental light and cues. So
it's your sixth, just so you know, Max, it's your sixth sense.
Sixth sense.
Like everybody knows about the five senses, but this is the sixth sense. And you know the cool part of this? This sense, do you know what the target of this sense is?
What?
I've never told anybody this, but now's the time. It's the POMC system. It's the leptin melanocortin pathway. That's exactly what the target is. So when you really understand, like you remember when you were a young doctor, you learned that the five senses coalesce in what part of the brain? The thalamus. All five senses come through a thalamus. Thalamus is the distal end of the diencephalon. The diencephalon is where basically the whole central retinal pathway to the end, the whole melanin system, the whole shit and caboodle that we talked about, it's right there. Mitochondria are informing anything with the name thalamus in it of what they're sensing. Your entire mitochondrial colony in you talks to the central retinal pathways, to the hypothalamus, and to the thalamus. That information is then relayed through the thalamus up into the two frontal lobes, the two parietal lobes, the two occipital lobes, and then the two temporal lobes. And what happens from there? The efferent loop in those lobes, that's the motor loop, then comes down. That's the input and the output. And it turns out what really controls those two loops is circadian biology. So let's tie this nice bow for you. How does all this process work? Well, guess what creates the alpha wave in the brain? The thalamus. Did you know that?
No.
That's how circadian biology links all this. And what does the alpha wave in the brain? What's its molecular resonance? 7.83 hertz. You know what has a molecular resonance of 7.83 hertz in nature? The Earth. That's the Schumann resonance. That is just how incredibly sensitive this system is. You are designed to be quantum coherent with the heartbeat of the planet. And the heartbeat of the planet is created by the sun and the planet. It's the cathode ray and the anode. And what ultimately, how is that Wi-Fi connection maintained? Through the hydrogen bonding networks of the water in your body. How do you like that?
Wow.
When you begin to understand how incredibly important this system is, then you start going, now I understand why circadian biology and all this physics that Jack talks about is important, because it determines all those space-time continuums in the zip codes in your cells. It determines the compartments that we learn about in biology.
Yeah.
That's what keeps the redox potential, idealized in our parathyroid glands, in our kidney, in our liver, in our gallbladders, in the beta cells in the pancreas, in our testicles, in our ovaries, in our uterus, so that our uterus sloughs the right way. So, we don't have, endometriosis and things like that. When you begin to understand that these very basic processes all link together, and you see the 100,000-foot view of how they link together, you fall back in your chair and go, wow.
Yeah. And that's what
This is pretty incredible.
And I think what the rigor of or the validity of a hypothesis is the degree to which it can explain phenomena. And what you're presenting and what we've laid out in these hours is a theory, a framework that is more explainable than anything that I've heard of in terms of biology and health and human health and disease. And so, I mean, that's why I'm so fascinated about it, and that's why we're recording this amount of content, is because I think, to me, this is the closest or most accurate approximation of how the human body works and how health and disease is manifested. To continue on that point and get clarification on this idea of developing mitochondrial chaos when we eat foods out of season. What Jack was saying is that if you're living down here in Albury, New South Wales, Australia, and we're just coming into winter, and you start eating bananas, which are obviously not able to grow at this latitude, at this temperature, with this amount of photosynthesis, then you're creating inflammation and chaos, which I'm guessing what you're saying, Jack, is a mismatch between the environment.
It's a circadian mismatch, Max.
So on a cellular level, like,
you got really excited there. When you're starting to put things together, you knock your microphone.
Yeah. So
that's good.
So explain to the conventional MD who's thinking on a level of cytokines and these type of frameworks, how exactly, what do you mean by chaos, and how exactly does that cell become dysfunctional when we're putting the banana in at an inappropriate seasonal time?
Yeah, I mean, the if you want to take it all the way from that level, you're interrupting the 7.83 hertz signal that your thalamus and your colony of mitochondria are paying attention to. So how does the mitochondria immediately respond? It changes something called the IMJ, which is the intermitochondrial junctions, where the crystal membrane is supposed to all marry up to create the ideal electromagnetic pulse that a mitochondria produces, which is negative 400 millivolts, which corresponds to an electric charge on the intermitochondrial membrane of 30 million volts. So now I just went from the physics to the electrical engineering. When you can't create that amount of energy, remember all those things that all these doctors learn about the ATPase, 3.4 H plus ions have to get out through the ATPase to make water. There has to be 9,000. So now when you eat the banana, now you can only get maybe 7,500. And what's the ultimate effect in the CSF, in your heart, in your blood? It's all the cytokines that you talked about. IL-6. Let's think about a good one. NF-kappa beta. Those
TNF
are the ones
alpha.
that most docs don't measure, but where you'll be able to measure them is in highly sensitive cardiac CRP, or say their haptoglobin level. What else could I give you? All of these things will go up. Why? Because the electrons get subtracted out because the protons are now beginning to dominate. And what does this all do? In and around that leptin melanocortin pathway, in the central retinal pathways, in the thalamus. The thalamus becomes less able to sense this whole process because guess what it's designed to do? That's Schumann resonance. It's telling your thalamus where you are in relation to the sun as it revolves around the planet. And ultimately what happens, you create all these biochemicals that you learn that actually are favoring H plus and not electrons. And what does that do? It reduces the charge that can be made between cytochrome 1 and oxygen. And you'll be okay if you go between negative 400 and negative 200. If you drop below 200, because let's just say you like bananas and you're going to continue to eat them all day long throughout the whole winter, eventually, if you do that long enough, you're going to wind up with a big problem because your redox is going to drop in certain tissues.
Yeah. So
That's really how it happens.
Essentially, it's reducing the efficiency of your mitochondrial function when you're eating these foods out of season.
Correct. Remember, I always tell doctors it's very easy to understand this paradigm. What do we call a body with energy? We call it a human life. Those are our patients. What do we call a body that has no energy? A cadaver. See, the body is the same. What's the difference? It's the physical organization, the atomic organization of the living state that's different. Like if you look at rigor mortis is the only time humans truly are at an equilibrium state. We're designed to be far from equilibrium as we live. What keeps us far from equilibrium? It's that energy production in a mitochondria. It's the electromotive force, or how I like to describe it is delta psi, on your inner mitochondrial membrane. Add it all up, and that tells you what we're doing. And it turns out most of that is driven by the collection of H plus inside the matrix, and also by electrons that are flowing in the system. And if you really add it all up, I've done the math on it. It's about 75 trillion volts of electricity are in a healthy 70 kilogram adult.
Wow.
And everybody seems to know in medicine, we can measure different deflections and curves. I mentioned one already, which is the alpha wave in EEGs. Most doctors who will listen to this can do the same thing when they put EKG pads on people's chest. What are you measuring? You're measuring the electrical potential of the cardiomyocytes in the person's chest. That's a function of the colony of mitochondria there. The EEG is a function of mitochondria here. We have now MEG machines. MEG machines measure the magnetic flux coming from both organs. We can measure that as well. So those are also measures of redox. And I don't think that even doctors realize that the things that I'm saying here, these are easily measurable. When I look at an MRI, am I doing the same thing? Absolutely. Now, it's a little bit different because remember, MRIs really work on physics properties. But remember, neurosurgeons deal with MRIs all the time. So why did I become facile with MRIs and cardiologists become facile with, the electrophysiology of the EEG? That's what or EKG, I should say. That's because what they use. Neurologists use the EEG. I use EEGs too. I don't think they're as useful as MRIs are, but I'll use them for different things. The point that I'm trying to make is that we are beacons of light that create DC electric potentials in us. And the way in which we do that is completely by using nonlinear optics. And the key points in that is understanding light, water, and magnetism, but understanding what are the key chemicals in you that really determine this issue. Well, I've kind of told you the first 3 hours, that melanin thing is a really big deal.
Yeah.
It creates more free electrons than just about anything in a mammal. And I would tell you that when you fundamentally get back at a patient in a chair and you're trying to explain this to them, explain to them very simply that you have to improve their environment so that they can repair their insides. That's really how your system is built to operate. And if you can create a good enough environment for them to do the right things, I don't think there's anything easier in the world than telling a patient, I want you to eat what the farmer says grows at your latitude. End of report. If I can get a patient to do that, even if they eat crap that I don't want them to eat, I'm not going to scream at them. We have to make this really simple for patients to understand. I think personally, you have a tougher job than I do. Why? Because you live in a country that has absolutely demonized the sun. I'm going to tell you. I don't think you're going to get anybody regenerating if you block the sun.
Yeah. Yeah. And Jack,
even if you use cold tremendously, I just think you're hamstrung at the beginning, and you're always going to focus in on diet. You're just going to say, it's got to be diet. It's got to be diet. Well, I'm sorry, dude. I'm not that guy.
Yeah. And I want to really step this out for the physicians who are and those who are really thinking from a metabolic and kind of insulin resistance point of view. So we've eaten, and let's continue on this thread. We've, say hypothetically, we're eating the bananas out of season in the lower latitude. It's creating this dissonance within the mitochondria. It's reducing the efficiency of the mitochondrial function. It's impairing the environmental signal that is being sent to the thalamus about the coherence of the individual to the solar point of the year. And what is fill in that little bit between that development of mitochondrial impaired function and full-blown diabetes, insulin resistance and leptin resistance. Because what I'm feeling is that the development of insulin and leptin resistance and then full-blown diabetes is simply a manifestation of metabolic dysfunction on a subcellular level.
I mean, I think diabetes is 100% tied to the light in our environment. My current blog post that's out actually is about that very issue. It says diabetes comes from a problem with POMC, specifically two parts, the left side of the POMC gene. And once you understand that, it doesn't mean that it can't be exacerbated by other things. That's absolutely the case. But where does the functional breakdown start? And then there's people that always, say to me, well, diabetes was around before Tesla's AC power grid. I'm like, yeah. But you don't realize this story really started when humans started putting clothes on. If you want to be really accurate about it, it probably began at our genesis when we put societal norms on people. And can we even see the basic factor in the building of the pyramids in Egypt? We can. The Nubians, who had the darkest skin, which would mimic, the Aboriginals in Australia, when we dug up their bones, we found they had perfect skulls, perfect jawlines. Their skull was real thick. But we know from studying the Egyptian mummies, they were train wrecks. Why? Because they lived inside the palaces where the sun wasn't. I mean, you don't have to have a cell phone up to the side of your head to get these processes. The problem is how you live your life in the environment is a story that is literally eons old. And I try to tell people this. People ask me all the time, well, people got cataracts, 1,000 years ago. We know that. I'm like, yeah, you're right. Do you not think when you have a cloudy day that more cosmic radiation gets in? Did you know that? Most people look at me dumbfounded, say, no, I didn't know that. So guess what? On Earth, the electromagnetic spectrum, like when we talked about the Kelly brothers, everybody makes the assumption that, oh no, it's only visible light that gets through all the time. That's not true. When a bolt of lightning hits relatively close to you, you're creating gamma rays and X-rays. If you don't think that those have an effect on us, they do. But guess what? We're the mammal that has an epigenetic toolbox that can fix a lot of that stuff. The problem is, if you happen to live around a ton of this stuff like we do today, that's where the game changes.
Yeah. And
once you understand what I've laid out for you, on the POMC side, you get it.
Yeah. And I want to make the comment about the ancient Egyptians, because they were inside, but they were also eating heaps of wheat. And we know that because their molars were ground down from the sand that was being used to grind the wheat. So what Jack mentioned about the amount of mitochondrial water that's produced when we eat a high carb diet, you can see why they were getting acute myocardial infarctions.
Max, I would tell you something else I want you to think about. I know you like telling people about the diet, but I want you to remember something else that I don't want anybody in Australia to forget. They lived in a desert, just like you guys do. Deserts are not bueno for things that have mitochondria, just so we're all clear. I agree with you that the wheat and the grasses are a huge problem, but I also want people to remember the 28th latitude in northern Africa, that is Sahara Desert territory, where the water's not good, the sun's great, but life does not like that kind of situation. That's the reason why deserts are called geopathic stress zones for mitochondria. You have to have massive adaptations to your physiology to live there. And the reason why I think what you just brought up is important, the reason I interrupted you is not to be an asshole. Remember, your continent is filled with Northern Europeans who have defects in their skin that remigrated back down to Australia. Okay? Don't forget that.
Yeah. And that's fascinating anthropological evidence of the overweight and AMIs, written in of these ancient Egyptians, and it was depicted in hieroglyphics and in and statues, and there's rulers with man boobs and abdominal obesity. So they were not a healthy population, it seemed like. I want to go back to a point that you made, that when you were describing the importance of burying mitochondrial density in our heart and our brain and not in our physical structure. And you made the point that sometimes you can look like Michelangelo's David and yet not be in a state of health. I guess a point that might push back on that is a perspective of health that is appearance and performance. So yes, there's some cases where a ripped bodybuilder might be on the teetering on the brink of poor health because he's perhaps hypertrophied his muscles and worked out all day under blue light and looks physically in a good shape, but is in fact not very well. But if there's someone who physically looks good and has high performance and has low amount of visceral fat, more often than not, I would assert that person is in good health.
Yeah, but most people that have hypertrophied muscles don't fit that bill when you look inside them with MRI. And I'll submit something else to you, Max. Deny this reality. How many 85, 90-year-olds or super centenarians do you know that look like Michelangelo's David? The answer is zero. And you want to know something else that's interesting? We have a guy in the United States named Nir Barzilai who studies them at Albert Einstein in New York. You know what you find out in humans that live over 100 years old? They're short, little, chubby guys. And here's the other interesting thing. The best performing athletes on the planet today, they're the Sherpas. They don't have hypertrophied muscles at all. So the question I would submit to you is maybe your paradigm needs to be changed a little bit. I'm not trying to tell people that having hypertrophied muscles is necessarily a bad thing. What I'm saying is don't assume because you got them that you get a pass.
Yeah.
In fact, the data shows something more dastardly, that people that do have hypertrophied muscles tend not to live long at all.
Yeah.
And there's a reason for that. This is the reason why I get into kind of pissing contests with guys like Peter Attia, because he's telling people that if you hypertrophy your muscles, it's the best way for you to deal with insulin and glucose. And I've already told you in the first 3 hours, I totally disagree with that. And the problem is no one is taking into account really how this totally works. It's not your muscles that are the sum for the glucose. Your mitochondria are the sum. And it turns out your mitochondria all over your body are built to do it. And the Sherpas, I mean, remember what I told you about gorillas and chimps? This is really, really important for you to hear. The humans on this planet right now that are the strongest pound for pound are the Sherpas. They can lift normally 3 to 4 times their body weight. Now, if you go listen to Peter Attia, he'll tell you if you can just double your body weight, you're a rock star. These guys are 3 or 4 times, and go look at them. They're 5'4", 5'6", tan, and they don't have big muscles. And they eat sticks of butter. As they go up the Himalaya mountains carrying all the Northern Europeans' gear. So when I give you the best performing athletes, then I give you the longest living humans, and neither one of them fit your model, then guess what, Max? It's incumbent upon you of telling me why I'm wrong.
Yeah. Yeah, and look, I agree completely that it's not an optimal health strategy to go to the gym and get jacked and have non-functional muscle. My opinion is that performance and agility and ability to use that muscle functionally is the key. The interesting thing that I think we might both agree on is that the presence of visceral fat on MRI is going to be a predictor of poor health. And I mean,
absolutely,
and
or redox.
Yeah, and if you've got
no question,
if you've got visceral fat, that and I've talked about this with Dr. Sean O'Mara. You could check out that podcast. That is the single thing that you need to be doing the most about in order to improve your longevity. And perhaps the 100-year-old New York man that you just mentioned, Jack, who was a little bit chubby, I would wager that person has subcutaneous fat depots and not visceral fat depots.
Correct. Absolutely correct.
Yeah.
There's no doubt about it.
So,
but you have to also realize the question everybody needs to ask is why are we getting the deposition of visceral fat versus subcutaneous fat? And guess what? When you parse that out, guess what answer you're going to find? Is a melanin problem. Actually, in the pathways that we talked about in the first 3 hours. And it turns out, because of our environment, the way it's changed, that specific pathway, I can actually tell you who's going to have fatty liver by looking on their eyes. There's a somatotopic organization on their eyes that will predict visceral fat. And I can always tell you where it's going to be. It's always going to be right around the macula. It's going to look like a machine gun. Took it out.
So,
and the most interesting thing about those people, they also have a 1.7 to 2.7 higher risk of cognitive decline and neurodegeneration. That answer is right there. It's a melanin problem.
Mm-hmm. So yeah, we can agree that again that the visceral fat is a problem, and we look at certain genetic groups, say subcontinental, South Asian, Indian, East Asian, their predilection to putting down visceral versus subcutaneous fat seems to be much increased, and they can have a normal body mass index, but have a large depot of visceral fat and be floridly type 2 diabetic and insulin resistant. So are you suggesting that in those patients particularly have more pronounced dysfunction of the leptin melanocortin pathway than perhaps a Northern European who is?
Absolutely.
And what factor?
The same thing is true. The same thing is true in the same thing is true in the what do you call it? The Eskimos in Alaska.
Is that because they're
We've seen
in a
huge
more
changes.
inappropriate light environment for their biology than the Northern European?
Correct. Now they are. That's what's happening to the Aboriginal.
That makes a lot of sense. That makes a lot of sense.
Yeah. And not only that, but also the Aboriginals that are in Australia, their environment has been completely changed by the use of technology. And the funny thing is, they don't have to look that bad, but if you look in their eyes, it's incredible. I've asked doctors in Australia, I said, how many times do you see somebody who's got fatty liver, diabetes, who is drug addicted or alcoholic? You actually look in their eyes to actually see the correlation between skinny and fat diabetics. And Max, I'm telling you this as a doctor, my current blog actually lays out why certain people get, what I like to call United States type 2 diabetics who are fat, and then the skinny diabetics that show up on the subcontinent of India since Facebook and Google have moved their places there. There's a reason that we're seeing this, and this is the crazy part. The fastest group of diabetics growing on this planet is actually in India. It's not in the United States, and it's not in Australia. And there's a reason for that. And they're different. They're very different than what we've seen in the past. And it's our job as physicians to point this out to other physicians, because the problem I have is that when someone sees somebody with non-alcoholic fatty liver disease, they automatically assume these people are eating too many carbohydrates, and drinking too much alcohol and all the other things that go with it. They haven't actually thought about the physics. And I always ask them, have you looked in their eyes yet? Have you actually done an MRI of their brain? Have you seen any changes there? And they're like, no, why would I do that when, I think this is a liver problem? I said, well, what innervates the liver? The vagus nerve. I said, where does the vagus nerve come from? It comes from the floor of the fourth ventricle, right where that CSF is. What's interesting about the floor of the fourth ventricle, Max? Has no blood-brain barrier. Oh, remember? We're back to that water story. But what else is interesting about that? Well, what connects the third ventricle to the fourth ventricle? It turns out the third ventricle and the aqueduct ileus are actually diencephalic derivatives. Oh, they're supposed to be loaded with POMC. Oh, really? Can you see that effect? See, the point I'm trying to make here, this is what you just brought out, is a beautiful thing. This is the Dunning-Kruger effect for modern central biology. What you don't know, if it turns out to be the most important part of the equation, you keep blaming the wrong things. And all the other things that the Aboriginals have, the same thing that's true with the Eskimos in Alaska. They are afflicted by low dopamine behaviors and problems. That is a POMC issue. And the problem is we haven't done a good enough job in centralized medicine to realize that we create dopamine from melanin. I mean, it's beyond me how people have not put two and two together. But when we tell people, we just need to take their booze and their I don't know, Frito Doritos away from them and it's going to solve the problem. It's not. You're going to have to change their light environment.
Yeah.
You're going to have to actually put them back in the environment that they're best adapted to.
Yeah. I mean, that makes sense to me. Can you clarify a little bit more about what exactly you see on the macula or through on examining of the retina and perhaps on MRI brain that correlates to metabolic dysfunction and fatty liver, and what clinical application, if any, is there to perform those scans?
You're going to see white matter changes along the pathway of the inner retina, the area of the retina around the macula, things that affect the hypothalamus, and then into things called the medial longitudinal fasciculus, down into the nucleus accumbens, the locus ceruleus. All of these places will have white matter changes present. And people always get, when you do MRIs, radiologists are really classic about, oh, these white matter changes and they're tied to hypertension. No, they're not. That's what the convention is, but it lays out a path clearly for me that shows this is where these patients are losing melanin throughout their entire neural system. Now, Max, I'm not going to assume that you know human embryology really good, but one of the things that I've become pretty expert on the last 20 years because I realized it was important, I had to go back to the embryology book to see what the neurulation patterns were between the neural crest, melanin, and where it goes in the adult brain. And you'll find out that everything that goes to the gut goes through very specific pathways that channel back to different portions of the RPE. So what I look for 3 o'clock, 6 o'clock, okay? But the worst areas are the inner portion of that retina. That's where these people who have non-alcoholic fatty liver, they're going to show up. And they're also the people, they're going to wind up with drusen in their eyes at that level. They're also going to wind up with AV nicking in that area. They're going to have unusual changes in that part of their retina. They'll get diabetic retinopathy changes before they'll ever get the metabolic disease. But you know what the problem is, Max? And I know you know this. Now I'm going to throw our profession under the bus. How many primary care doctors in Australia take a look at their patient's eyes when they do a physical exam? Let me tell you the answer.
0%.
Take a look at the screen.
Yeah, it's none.
0.
Nada.
Yeah, well, guess what? The same thing is true in the United States. But guess what? That needs to change. Why? Because you said you had a doctor on that did a podcast that said this is the best effect. I got some bad news for your doctor buddy. The most sensitive test that you can order, even if you don't have the skill set to do an ophthalmologic examination on your patient, is an OCT. You can order it, and the OCT will tell you where the retina thickness is abnormal.
OCT.
That's all you need to know. When you see that, OCT.
So
it's amazing.
Ionizing
it's
radiation.
A test that is readily available in most imaging centers anywhere in the United States. The people who tend to use it tend to be retina specialists. Doctors, primary care doctors, should pay attention to the bigger factors. What's the first effect of a low dopamine brain? You know what it is, Max? It's myopia. Anybody who has myopia or is a high myope, you know by definition has a problem. Anybody who has a history of a cataract, by definition, has a problem. Anybody who's got the beginnings of any retinal diseases like AMD, by definition, has a melanin problem. Now, the interesting thing is when you take this information and go back to your own practice, you're going to say, well, when I document the patient wears glasses, do you ask them, do you have presbyopia or myopia? In fact, you should get on the phone after this podcast and talk to your local ophthalmologist and say, how many people do you diagnose with presbyopia versus myopia? You know what you're going to find? It's 100 to 1. You know why? Because everybody uses this
Devices.
Right here, Max.
The device, yeah.
Right in front of their face.
Yeah.
And what does that do to the globe? When the dopamine level drops, the first thing that happens, the globe becomes oblong. It's no longer circular. What do you think that does to all the optics in the eye?
Distorts.
What did I tell you in the first 3 hours? When you change the optics, you change everything.
Yeah. And
I know it's hard to believe. I'm asking you to suspend your belief on what you were told, but I promise you, you are going to be stunned when you look. And you're going to find out that different levels of POMC are in different parts of the retina. There's certain parts of the retina that don't have POMC at all. Guess where you're going to find that? Where Warburg metabolism is. But guess where you're going to find the most POMC? Where you have the biggest oxygen consumption in the body. Most people don't even know there's parts of the retina that use an FiO2 of 80%.
Wow.
It turns out those are the same places where those aboriginals get visceral fat. So guess what? There is nothing of the paradoxes for chronic diseases that I have shared with you now. Let's see how much time it is. We're now going on almost our 7th hour. Every single thing comes back to that first podcast. So light and water are back to this. Remember what I told you about melanin? Best charge separator to create electrons in the world. Do not forget that basic fact.
Yeah.
Because when you have non-alcoholic liver disease, you can't create enough electrons in your liver.
Mm. And the point that you make about low dopamine state and causing the globe distortion in its physical structure and therefore a refractory error and requiring glasses, I mean, that feeds into, that makes sense to me, and it feeds back into that question that I asked you at the end of the first podcast, which is the observation that so many young people these days are requiring glasses, and frequently that observation is accompanied with premature balding decades before their fathers. So again, it's not a genetic thing; it's an environmental cause.
Well, I want you to think about this, Max. You live in a neck of the woods, close to Asia, and I know you probably know this better than the doctors in the United States do. There's a syndrome in Asia called the celibacy syndrome. Most Asian kids are myopes. 96% of Asian children are myopes. There's something called the celibacy syndrome that comes. So immediately you, as an Australian doctor who just got, infected by Dr. Kruse, should go, okay, now I get it. If you become myopic, it's much more likely you're going to lose POMC hypothalamic neurons that control GnRH, control all the sex steroid hormones.
Yeah.
And what did I just tell you? That things with POMC happen faster than we all think. Well, I'm telling you that kids that normally would, families would be keeping their daughters away from 15 and 20-year-old men, they don't have to worry about that anymore because Samsung has made sure that they put the phones in front of their face.
Yeah.
It's not just the hair fall. These effects are everywhere you look. The problem is you have to be a good doctor to take what you now know, this new information, and go, wow, this explains this too.
Yeah. Yeah.
And I know it's hard for you to believe, but I want to take you back to something that we said, maybe we can end on this because I'm going to have to go back to the hospital. They're texting me now.
Yeah.
But I want to take you back to something that we said that'll put a nice bow on this. I want you to think about non-alcoholic fatty liver disease the same way we talked about the difference between human babies and chimps. Remember I told you that we have sub-Q fat underneath our skin to regenerate our brain, right, as we grow. What if I was to tell you that the reason why we have fatty liver is because our liver is being destroyed thermodynamically by not having melanin in the right part of our eye and our brain, and the body is storing fat in that liver so that it can be turned back into water to regenerate electrons to rebuild your liver. And I know Max is a smart guy. He knows that the one organ in the gut that has the most regenerative potential is the liver, right? We can cut a lobe out of the liver and you won't miss that at all, correct?
Correct.
So instead of thinking about non-alcoholic fatty liver disease the way your last podcast told you, how about if I told you that's where all the stem cells to rebuild the liver are located? And it's your job to get that person back in the sun to create the ferroelectric current to turn that fat back into the liver. And the name of your podcast is the Regenerative Health Podcast, right?
Sure is.
It's not the low-carb, high-fat bullshit network of insulin and carbohydrates, right?
Yeah, correct.
Just putting it out there. Hopefully you don't cut this part because guess what? I know it's controversial, but the point that I'm trying to make to you, we already talked about children and water content being at 80%. What I'm trying to tell you is that this non-alcoholic fatty liver thing, no question it's pathologic, no question that it's a problem. But I want to tell you that the same physics that's in the immature brain and the sub-Q fat exists in the sick liver and the fat in the liver.
Does that mean that visceral fat has similar, are you implying that visceral fat has a similar intended purpose by the body for?
Yes. The body is trying to reserve time. That's what fat's all about. If you ask any plastic surgeon in the United States and any plastic surgeon in Australia, where do they harvest stem cells now? From the fat. See, again, fat has a bad connotation. Now I want you to think, Max, what I just said to you before about Neobarzillai and the guys that live to be over 100 years old. They're short, little, dumpy creatures. Maybe, just maybe, the way Max and the way Jack learned what we learned needs to be questioned. Just maybe.
Yeah.
That's all I'm saying to you.
No, and I appreciate it.
I told you, I want you to think about these things.
Yeah, it's it's so much to think about, and I'm going to have to go away and do a lot of thinking. Before we finish, can you just tie a bow on that, the retinal CT scanning, and just explain how would we interpret that, and how could we justify dosing our patients with ionizing radiation for the diagnostic or prognostic value that it would offer?
You're not gonna be able to do this until you get training to do it. But if you sit down with your retinal specialist, you can do it. I did it. I just went out and bought a book about OCT and what it meant. And what I found out is that the first sign of childhood obesity is a thickened choroid. I also then found out that the first sign of non-alcoholic fatty liver disease is a thickened choroid. And I found out the reason why. And you will see when these pictures are generated, the choroid in these levels at different parts of the retina, because they give you a nice topographic map, you'll see it happen. And this will happen in people before it happens. So, for example, if you had somebody who was an IT worker come in, say from, I don't know, let's say Tasmania, and you knew they were in the basement and they lived at the 37th latitude, it was terrible, and they were always on the phone, and they told you, look, I just don't feel good, and you couldn't figure out really what's going on, you could actually order this test and find out if the choroid is thickened. You'd say if you continue on the path you're going to wind up with diabetes and non-alcoholic fatty liver disease, and you're going to start eating more carbohydrates and wanting to drink more wine. And your sleep is going to get trashed. And your brainstem is going to get hypermethylated. And they're going to look at you and go, Max, how did you know this? And you say, well, I ordered your OCT and I saw that your choroid is thickened. And guess what? All the things I just told you, they're published in the ophthalmology literature. But you didn't get told that in medical school. But it's there. Yeah. I promise you. You can go look it up.
Yeah, I'll
it's
look
in all my blogs.
I'll look it up.
I teach people this stuff.
Yeah, that's fascinating, and yeah, I'm just wondering. I mean, there's a bit of a long bow to draw under the current centralized medical paradigm in terms of the first line test. You know, if I walked into my training,
think you're crazy.
If I went into my training provider and said, I want to order a CT retina as the first test, I'd literally get laughed out of the room.
You would, but I want to say this to you. I want to say this to you as a doctor, but also to your audience, and hopefully you won't cut this out because it'll be spicy language. But it's not my quote, but it's so apropos for what I'm about to tell you. Smart motherfuckers look really crazy to dumb motherfuckers, especially initially. And I want you to really think about this. 20 years ago, I became so mad at my profession because I realized that we had the tools to do some of the things that you and I are talking about right now to actually help people. And the fact that I can have this discussion with you and you can go and fact check everything I've told you about the changes in OCT retinas, and you can easily talk to any retinal specialist. They can actually teach you how to read the OCT. They can actually send you to the school that they get sent to, because most of them don't learn it in their residency. It's something that is an add-on module that ophthalmologists who decide to specialize in retina surgery pick up. So that means if Max is interested in it, Max can go do the same level of training. No, you're not going to do it for the surgeries, but why are you doing it? You're doing it to find out where POMC is destroyed on that topographic map in their eye, so then you're going to know what diseases they're really at risk for. That makes you a better doctor, Max, because you know what? When you know better, your patients do better. So when somebody, a mentor, tells me I'm crazy, I think when they sit down with me for about an hour and understand the level of understanding that I have, all of a sudden it makes them very uncomfortable. And that's the way you need to roll, Max. Just realize something. The best way to change doctors, because I know you're trying to change patients, but you and I are both doctors. The best way to change doctors' behaviors is let another doctor know that you know something they don't know. Because you know doctors don't like that. They all think they know. Well, guess what? The best way to motivate a doctor is to say, what do you mean? You didn't know this? This is obvious. And then when they go look it up and find out that it is in the literature, they go, how did I not know this? That's the point. And I do this, Max, not to make people feel bad. I do this because I have found no way in 20 years to motivate our profession to be better than we are until they understand that we have to look under rocks to explain the things that are happening to our patients in the clinic every day that our biochemistry textbooks are. Look, if food could fix non-alcoholic fatty liver disease, okay, we wouldn't keep publishing, at least in the United States, 250 new diet books every year. I'm so sick of it. It's crazy. But it's so blatantly obvious where fatty liver came from as soon as we started plugging into a power grid. And we're making it now. We have kids that are 5 and 6 years old, but no one ever asks, well, could it be because they put an iPad and that's really the babysitter for the child who has non-myelinated brain and the eye isn't fully developed? No one ever thought to look there, but guess what? When you look in the literature, you'll find out the first sign of childhood obesity is a thickened choroid.
Yeah.
How do you like that?
But the thing,
don't
Jack,
you think that's something?
Jack, we don't have any kids who are shoveling their face with Pepsi and Doritos and French fries who aren't also exposed to sources of non-native EMF and blue light. I'm not saying you're not correct, but
actually, I'm gonna flip it around for you. I'm gonna tell you, the more kids use non-native EMF, the more of that food they're addicted to eating. And the reason for that is because the reward tracks in the frontal lobe are shot.
Yeah.
They have no acetylcholine and no dopamine.
Yeah.
That's the reason. See, this is the or I should say the chicken and the egg, that the argument you and I are having.
Yeah.
You want to focus on the food, and I'm perfectly fine with that, but I'm not going to go there.
No, I'm not.
Why? Because
I'm not
I know a little bit more about this.
Yeah, I'm suspending my position. I'm just advocating on behalf of most people who are going to be listening to this podcast. So my belief is I'm enjoying you really still manning and attacking this more mainstream position. So, and I'm learning so much. So don't think it's necessarily my opinion. My opinion is in constant flux.
No, I know. I know that. Yeah. I know we're doing this for educational purposes, but I want you to understand that the way in which we get people to think is we have to perturb them. Like, without chaos, Max, there's no progress. Like, why I said to you what I said to you before about your mentor and the spicy language that I used to do it, you laughed. And the reason why you laughed, because you're like, it's right. At one time, it was thought normal in the United States to x-ray children's feet to make sure their shoes fit them. Think about how crazy that is. But guess what? That was the dominant paradigm when I was a young kid growing up in New York. I remember going in the Buster Brown shoe place, and the guy wanted an X-ray in my feet. I told my mother. I was like 4 or 5 years old. I said, "Are you out of your mind?" And I had the sense that this was a problem.
Oh, that's a funny thought.
I still remember to this day when I was young, growing up in Manhattan, and my grandmother saying to me, "Don't lay on the ground close to the TV." It was a black and white TV to watch. I think I was watching a New York's Mets game at the time. She goes, because it creates problems, and my grandmother, I mean, when I tell you she knew less than zero about quantum physics, I'll never forget her telling me this. She was like an 80-year-old woman, and I'd laugh at her. And it turns out now I find out that cathode ray TVs actually emit X-rays, and she was right.
Yeah, grandma's wisdom. There's something special about them. They're incredibly intuitive, and that is fascinating. So I think that the last point I wanted to make about the retinal CT, I think maybe pairing that with an MRI scan for visceral fat might be a very, very powerful combination of preventative health.
But I think when you do the MRI, I would just tell you this: when you do, I think the future, and I think when you're my age, the future is going to be you'll do OCT, you'll do brain MRI, but you'll also do an abdominal MR, because I think at that time the cost of doing MRIs will be what the cost of doing blood work is.
Yeah.
Because to me, I think blood work at this point is almost the biggest useless thing we do in medicine. It confuses, because I don't think people really truly understand what blood work does. The most beneficial blood work that I do is peripheral blood smear.
Really?
And hardly anybody does those anymore. But, my members know about it. I wrote a Patreon blog about why I do it, and it actually ties to the story that I told you in the first 3 hours. I want to know exactly what the oxidation state of iron is in people's bodies, because then I know if they can maintain their redox potential or they can fix it.
Yeah.
That's what I'm interested in.
Yeah. Well, I think
that's what I said.
I was just going to say, I think we should do another whole podcast on the actual clinical questions. And we started on water and we got very clinical. But that's fine. It's been a fascinating discussion. But maybe we could do another whole section, because you've talked previously in your leptin blogs about vitamin D is a good proxy, reverse T3, all these other things. So maybe we'll do that and separate that discussion out. But today, sorry, Jack, were you going to say something? And do you want to finish this water podcast with any kind of like other final thoughts?
I would say there's other parts to water that we didn't talk about, not from the biologic perspective, but some of the things I think that we ended the first hour about, when we talked about Victor Schauberger. For those of you who didn't or don't know about him, please look him up. A lot of the original insights that I got about water actually came from his work back in the 1920s, because it fascinated me what he found. And, much like Max, and I think this is the reason I want to bring this up, Max just had the same effect when he said, Jack, if I go talk to my mentor and want to do an OCT, they're going to laugh me out of the room. I totally agree with Max, but I want Max to know sometimes the student is smarter than the teacher. And when I started to read about Victor Schauberger's work and what he did, I started to realize that some of my professors in neurosurgery, while they were all well-intentioned, they didn't have the whole story, and I needed to dig deeper. And a lot of the stuff that you heard probably in the first hour and 45 minutes that I did with Max, I would have never found if I didn't stumble on Schauberger's work in the 1920s. So please go review some of that. You can do that. There's plenty of videos online. Who knows, maybe in the show notes when Max puts this up on YouTube, if somebody asks a good question, I may drop an answer here and there. But I think you're beginning to understand light. You're beginning to understand water now. We gave you a couple of clues about magnetism, in this podcast, especially how magnetism links to light. And I guess the last thing I'll say, because I do have to go, is just remember, water is a magnetic dipole. So that means that this water story links to the next part of the story, which is magnetism.
Fantastic. Well, with that little teaser, we'll end this discussion. So thanks, Jack, again for an engrossing 2 hours, and looking forward to talking again when we continue this story. So talk soon.
All right. Take care, Max.